I'm delighted to introduce Miguel. He's a Chancellor's Fellow in STS, for those of you that don't know him, and he's going to be talking about a little bit more about the relationship between STS and bioethics. And Miguel's going to give a talk for about 15 minutes, and then we've got a esteemed panel who are going to all give a 5-minute sort of discussion and reflection on that. So it will be Cate Heeney, Jane Calvert, Steve Yearley, and then Emma Frow.
Okay, thanks a lot, Fadila. Well, good afternoon, and thanks for making all the way to the very end of the retreat to attend. What we want to discuss in this panel is how STS research and research into the natural sciences, and more particularly the life sciences, has historically evolved, and what are like the new and enduring problems of those interactions between STS and the life sciences. And well, the idea to organize this panel arose from a postgraduate course, which is convened by Jane and Emma. It's titled The Social Dimensions in Systems and Synthetic Biology. And I participated in a session which dealt with how the social issues around the biomedical research have been tackled in the past and in the present. So in doing the readings for that postgraduate course and discussing them between ourselves and with the students who were mainly natural sciences postgraduate, we realized that the problem of interdisciplinarity between STS and the life science is the result of very long-standing historical processes. And I think that by understanding better those processes and being a bit reflective, I think social scientists can acquire a new insight when they deal with cooperation with the natural scientists. And also historians can find a way to link their work on the past with the present, with current and broader issues in STS. So what I'm going to do in this historical introduction is to sketch what I think are the main highlights of this historical process of interaction between STS and the life sciences. And I'm going to propose, probably quite superficially, so feel free to argue against it afterwards. I'm going to propose 3 broad phases. Each phase is triggered by a development in the life sciences, and is founded on an idea of how research on the social, ethical, and legal dimensions of biomedicine should be conducted. So let's go with the first stage. The first stage is triggered by the development of recombinant DNA technologies in the mid-70s, and is centered around the idea of self-regulation. So recombinant DNA are a set of techniques which enable the isolation of the genetic material of a given organism and the transfer of that genetic material to another species. In the first experiments on recombinant DNA, the inventors use a series of genes from frogs, and they transfer those genes to a bacterium, which is E. coli. So when these techniques were invented and patented between 1973 and 1974, they were received with concern outside the biomedical community, because they thought these techniques could lead to the development of super-resistant viruses or bacteria, and even to the modification of the genetic material of humans. And there was a talk about the re-emergence of eugenics. So a selective group of leading biomedical researchers decided to set a voluntary moratorium on recombinant DNA research, and to meet in 1975 in Asilomar, which is like a paradise city in the west coast of the US in California, in order to discuss the ethical implications of recombinant DNA research. So this article, the Pandora's Box Congress, is one of the readings of this postgraduate course I was mentioning before, and it's quite a peculiar reading, because it's a very lengthy feature article written by Michael Rogers, who is a physicist, and at that point in 1975, he was a freelance collaborator of the magazine Rolling Stone. So you can see how popular and hot recombinant DNA was that. Rolling Stone was reporting on that. And what is remarkable of this feature article is that it's a day-to-day account of the meeting. So Rogers was attending all the meeting, and in his account, it is possible to see some of the arguments that there were transformed into arguments about this idea of self-regulation by scholars in the history of science, in science policy, for example, Susan Wright. So all Asilomar meeting was founded on the belief by the attendees, by the biomedical researchers, that if they didn't come with some sort of voluntary guidelines about how to handle recombinant DNA experiments, someone outside the biomedical community would impose those guidelines on them. So that's why they were obsessed by this idea of self-regulation, and they spent like sleepless nights in order to come with a conclusion at the end of the meeting. There was also a very interesting public-private dynamic in the meeting, in the sense that the biomedical attendees had lengthy discussions behind the curtains, and at some very concrete moments of the meeting, they called actors which serve as a link with the public, for example, journalists or lawyers, and they presented to them the results of their discussions. But an obvious consequence of this is that there was a gap between those public discussions, the guarantees biomedical researchers gave to journalists and lawyers that no superbugs would be produced, that no designer babies would be created, and what the scientists really wanted to regulate, which was something much more technical, much less sensational, and it has to do with the possibility to be able to isolate and to express in their laboratories without any interference genes which produce some substances of scientific or commercial interest. And in fact, that was the basis of the later biotechnology industry in the late 70s and 80s. So basically, scientists wanted to do what they wanted without interference, but at the same time, they wanted to be seen as addressing some public concern which has nothing to do with the real concerns. And as a result of that, people outside the mainstream biomedical community, and this includes social scientists, they weren't present in Asilomar, were excluded from the deliberations, and they were only given access to the results, to what was told to the journalists and to the lawyers. In fact, Rogers, the author of the article, is probably one of the very few cases of a person who was able to attend all the meeting. And that was probably because of their science background that he was given access to that. So this model of self-regulation was a success. Most Western countries and governments adopted the voluntary guidelines established by the attendees to Asilomar, and it informed most of the biomedical developments in the late 70s and most of the 80s. But the 80s is also a time of increasing activism in issues related to the environment, to health, even to the regulation of recombinant DNA, if we take the very early GM crops controversies. And these civic movements, these emerging civic movements, what they wanted at the end was a greater degree of participation in decisions about science and technology. And in this context, in the mid to late 80s, biomedical researchers engaged in a new large-scale project related to the mapping and sequencing of the human genome. So the Human Genome Project was launched in 1990 in the US, and in its early days, it met with a significant opposition in the scientific and in the popular press. So the director of the Human Genome Project in the US, a very prestigious biomedical researcher, James Watson, the co-elucidator of the double helix of DNA, and a very active participant in the Asilomar meeting the decade before, decided to devote 5% of the $5 billion budget of the Human Genome Project in the US to research on ELSI. And it is quite interesting that this acronym was spelled out differently, even in official documents of the same time. Some documents consider ELSI to be work on the ethical, legal, and social implications of human genome research, while others refer to it as ethical, legal, and social issues. And you will see that this slight difference is very relevant for what comes later. But the participants in the Human Genome Project used ethics as a shortcut to refer to this broad research area of ethical, legal, and social research. So ELSI, in its early years, was a field quite dominated by natural scientists. This is one of the very early books on that. You can see that they use issues instead of implications in the title. And this book had articles by James Watson, by other researchers involved in the Human Genome Project. And there was a limited space for philosophers and historians, but most of the philosophical and historical research was mainly epic narratives which justify the Human Genome Project as the culmination of the progress in molecular biology, from the elucidation of the double helix to the Human Genome Project, or very general bioethical reflections about the future of the Human Genome Project. But as time went on, and this is another book written in 2000, ELSI and its European counterpart, ESLA, which is Ethical, Social, and Legal Aspects of the Human Genome Project, our genomic research that was funded by the European Commission. This field evolved to be an increasingly autonomous field and to be integrated by a plurality of scholars, not only philosophers and historians, but also social scientists, generally speaking. So in the Human Genome Project, we can see that instead of the idea of self-regulation, the biomedical researchers behind the mapping and sequencing of the human genome decided to bring in the humanities and the social sciences and to create a field to which they devoted a small part of their research budget. And even though the idea behind ELSI and ESLA in its early years could be to sort of domesticate research in the humanities and the social sciences and therefore to silence opposition to the Human Genome Project, ELSI and ESLA acquired an own life as time went on and evolved independent field and professionally led research in the philosophy, history, and sociology of science. And also because of that, there was also a shift from research on the consequences of the Human Genome Project, on the imagined futures of the Human Genome Project, to an increasing critical engagement with how the Human Genome Project and more generally genomic research was being conducted now, was being conducted in the present rather than in the future. And I think for this shift towards independence, professionalization, and critical engagement with the present, it was very important that ELSI and ESLA acquire their own funding, independent from the natural sciences. And in this regard, I think the Genomics Network here in Britain was a very good example, and was also an example of the formation of a community working on genetics, genomics, and society, and wanting to have their own voice in setting the agenda around genomics research. And this leads to my last phase, which is centered around the idea of embeddedness and is simultaneous to the emergence of new approaches within the life sciences, such as systems or synthetic biology, characteristics of the so-called post-genomic era. The idea of embeddedness, well, I have said that it started in the mid-2000s, could have started earlier. Periodization is always very arbitrary, as Steve was saying yesterday. But with embeddedness, I mean that researchers in the humanities and the social sciences increasingly want to be directly involved in biomedical research, with the expectation of having better access to laboratory practice and capture them better, and also having an idea of how biomedical researchers think about ethical, legal, and social issues related to their research. And in fact, in the European 2020 program, the new European Commission program for research in the European Economic Area, there aren't calls specifically designed for projects in the humanities and the social sciences. And they rather want to the humanities and the social sciences to be embedded in broader problems which have traditionally been tackled by the natural sciences. So I think this idea of embeddedness, on one hand, represents an opportunity to engage with science and technology as it is being produced. But on the other hand, it has been concomitant to a crisis in the funding of the humanities and the social sciences. The Genomics Network doesn't longer exist as an ESRC-funded initiative, And in recent years, funding for the humanities and the social sciences increasingly comes from the natural sciences. So I think that also behind this idea of embeddedness, there is a threat that STS may become a bit the steward of the natural sciences. And we may return to a situation in which socio-ethical debate is used as an excuse for natural scientists to avoid real control, as it happens in Asilomar, or as it happens in very early ELSI research, that this control is postponed to the future of the research. So in the form of a bioethical research on the consequences of natural sciences research, which avoids tackling the social and political dimensions in which natural sciences research is actually embedding the present, and which I believe should still be the province of STS research, broadly speaking. And I'm going to stop now here and just leave the floor to my colleagues. Thank you very much.